Pluto made them come up and down. Pluto's circle crosses that of each other planet. Pluto, the puzzling little planet at the external extents of our close by planetary gathering, is running up further in the field of room innovation. Continuous surveys propose a reachable encounter with Neptune, raising issues among scientists and space fans. Recognized figures like Neil deGrasse Tyson and Michio Kaku have sounded cautions about the aftereffects of this galactic occasion. However, how did Pluto end up on an intense training with its connecting planet, and what could this glorious battle infer for life on Earth? Join us as we loosen up how something enormous just collided with Neptune and how scientists have been left confounded by this incredible inconsistency. Pluto, once hailed as an uncertain planet, went through a change in its status, being renamed as a diminutive person planet as a result of its magnificent circle. No matter what, this minimization, Pluto still charms and interests the cosmic local area. Later assumptions from trustworthy scientists like Neil deGrasse Tyson and Michio Kaku have raised concerns about Pluto's direction possibly meeting with Neptune, showing an approaching series of accidents among the sublime bodies which can have critical repercussions for Earth. Pluto's excursion across the Sun stands out because of its novel attributes within our planetary association. Its circle is shockingly delayed, crossing an exquisite a long time since its discovery in 1930. Pluto presently can't seem to finish a full upset around the Sun. Adding to its quirk is the particularly extended condition of its circle, a departure from the more round ways followed by the essential planets. Other than, Pluto's circle wanders off by 17 degrees from the ecliptic plane, giving its way a more outrageous grade contrasted with different planets. The blend of Pluto's nature and its bended circle presents layers of intricacy to its orbital design. One huge point is its incidental assembly with Neptune's circle for around 20 years during each cycle. Pluto adventures nearer to the Sun than Neptune, opposing assumptions based on their different situations inside the close by planetary gathering. Plunging further into Pluto's circle, it's interesting to note that it's anything but an ideal circle, yet maybe a stretched circle, like a greater amount of an oval shape. This extraordinary circle brings about critical varieties in Pluto's separation from the Sun during its venture. At its nearest approach, Pluto goes inside a 30 galactic units of the Sun, while at its farthest point, it arrives at in excess of 49 Australian dollars away, twice the distance of Neptune from the Sun. Besides, Pluto's circle is leaned at a critical point comparative with the circles of the major planets in our planetary gathering. This tendency not just adds to the intricacy of its circle yet, in addition, plays a critical job in its collaborations with other radiant bodies, especially Neptune. When Pluto experiences Neptune, their gravitational posts influence each other, altering their courses over time. The intricate dance among Pluto and Neptune highlights the unique idea of our close by planetary gathering. While Pluto was once viewed as a single vagabond in the external arrives at, its close encounters with Neptune highlight the interconnectedness of heavenly bodies, each applying gravitational forces that shape the ways of others. In later years, updates in observational innovation have permitted cosmologists to track Pluto's movements with wonderful exactness. This has prompted a more profound comprehension of its circle and its likely ramifications for the dependability of the external planetary gathering. Despite the fact that the opportunity of an immediate impact between Pluto and Neptune remains low, the probability can't be by and large excused, prompting observed also concentrate on by the cosmic local area. In spite of its unobtrusive size and remote location, Pluto keeps on telling consideration and interest among researchers and fans the same. The inquiry emerges: why hasn't there been a crash among Pluto and Neptune? The response exists in the gravitational draw from different planets. Space experts started examining Pluto's way not long after its discovery, and its direction bewildered them. Dissimilar to most planets that stick close to a similar plane as they circle the Sun, called the ecliptic plane, Pluto stands out with its precarious point and oval-shaped circle. The mystery extended once they understood Pluto's way crossed is Neptune. Regardless of these intricacies, Pluto's circle stays stable, exhibiting the many-sided mechanics of room. Understanding Pluto's circle is pivotal, particularly when considering on the off chance that it would be able to crash into Neptune later on. This information assists us with seeing better how our whole nearby planet group works. Pluto's circle instructs us that even circles that seem unsafe can adjust on account of gravity and how things move in space. Proceeding to study and break down these subjects is fundamental for extending our insight into the universe and our place inside it. When we investigate space, we find that things can be odd, and Pluto's circle is an extraordinary illustration of that whimsical ISM. Pluto's circle isn't like those of different planets. It's more oval-shaped, meaning it's anything but an ideal circle. Here and there, it even draws nearer to the Sun than Neptune does. This can make things intriguing because Neptune is likewise moving along its course. There is a little possibility that Pluto and Neptune could IDE with one another, but regardless its remarkable circle, Pluto figures out how to stay away from Neptune more often than not. This is due to something many refer to as gravitational forces. Gravity is like an undetectable power that pulls things closer to one another. So, despite the fact that Pluto and Neptune might appear as though they are on a collision course, their circles are cautiously arranged moves directed by the draw of gravity. Pluto's circle instructs us that space is loaded with shocks. What appears to be tumultuous from the start look can be a fragile equilibrium of powers. By concentrating on Pluto's circle, researchers acquire bits of knowledge into the convoluted mechanics of our planetary framework. This continuous perception and investigation are basic for growing our comprehension of the universe and our place inside it. Assuming Pluto and Neptune impacted, it would be a galactic occasion, sending shock waves through how we might interpret the close by planetary gathering. While we have gained ground in figuring out space, current occasions show that we actually have a long approach. Zeroing in on what colossal planets mean for Pluto's bearing gives us significant clues about how our whole close by planetary gathering works. It shows us that where every planet is and how it moves can change the ways of others in space. Despite the fact that space is complex, a few top researchers are worried that Pluto could slam into Neptune. This makes them can't help thinking about why this could happen despite the fact that it appears impossible. Neil deGrasse Tyson, a renowned space researcher, makes them interest considerations about Pluto. He trusts that renaming Pluto as a bantam planet, not a huge one like Earth, is a forward-moving step. He thinks we are continuously learning new things about how things move in space. Tyson sees Pluto's surprising heading as a signal that there's still a lot of we don't realize. He trusts that the mysteries of space are so interesting. He additionally knows that large occasions in space, like Pluto's renaming, get individuals associated with cosmology. Tyson needs to help individuals figure out the cool and some of the time peculiar things about how space capacities. He believes it means a lot to discuss how space mechanics can stun us. Tyson works with different researchers to caution individuals about the possible dangers of Pluto's circle. Directly following zeroing in on Pluto, much the way that it would be able to crash into Neptune sooner or later, makes him concerned. He says this could cause huge issues for our whole planetary gathering. A mishap between Pluto and Neptune could be a stimulating and serious occasion. If it could produce a parcel of energy and could fall to pieces, Pluto pieces from the impact could fly around space and hit different planets and moons. Neptune may likewise feel the effect and have an impact on the manner in which it moves. Prestigious theoretical physicist Michio Kaku, known for his contributions to string hypothesis and science correspondence, offers an intriguing perspective on space investigation. He immovably trusts that understanding the fate of room travel and the connection between divine mechanics and theoretical material science can be gathered from concentrating on idiosyncrasies like Pluto's circle. Kaku thinks about Pluto's circle to be a window into the future of space investigation. By getting a handle on the complex gravitational connections and orbital dynamics of divine bodies like Pluto, we can work on future space missions, helping with more secure route through the nearby planet group, anticipating expected dangers, and arranging missions to remote corners of our vast area. Kaku stresses that examples gathered from Pluto's circle can be applied to investigating other radiant bodies, giving a guide to unraveling far-off universes. He habitually features the profound association between divine mechanics and theoretical material science, emphasizing that the developments and connections of planets, including the gravitational dance among Pluto and Neptune, are established in major principles of material science. Kaku's work in theoretical material science, explicitly string hypothesis, means to unwind these standards at their center. He recommends that centering on the intricacies of heavenly mechanics, like Pluto's circle, can give insights into the fundamental laws of the universe. Like Tyson, Kaku has moreover mulled over the expected impact of great bodies, alluding to it in his theories about the universe. An accident among Pluto and Neptune, while huge in space science, could give a remarkable observational opportunity, possibly adding to our comprehension of string hypothesis. String hypothesis, which replaces point-like particles with one-layered strings, looks to make sense of the key forces and matter in the universe. Such an impact could make outrageous states of energy and gravity, revealing insight into the way of behaving of central particles and powers under outrageous circumstances. Additionally, the gravitational waves delivered by such an effect could give valuable data for testing expectations of string hypothesis with respect to gravity and spacetime. While the immediate effect on Earth would be unimportant due to our distance from the external planetary gathering, the logical ramifications could be significant. Understanding occasions like this could expand our enthusiasm for the major nature of the universe, as depicted by string hypothesis and other hypothetical material science areas. Pluto's unique qualities, inspired by the gravitational powers of adjoining planets, particularly Neptune, highlight the complex and dynamic nature of room. Yet, the universe holds numerous insider facts, and the three-body issue is just one of them. Researchers expect other likely disasters, highlighting the continuous quest for information and investigation in the immense universe. Despite the fact that it's profoundly impossible, there's as yet a little possibility of planets experiencing each other in space. This could happen because planets' ways are impacted by different elements like gravity from different planets, which researchers call the three-body issue. In places like the TRAPPIST-1 framework, where there are 7 Earth-sized planets, the gravitational powers make a sort of dance in how the planets move, brought orbital resonances. After some time, these resonances can make a planet's way less steady and could prompt crashes. However, frameworks like TRAPPIST-1 are overflowing with planets. Crashes aren't occurring right now. Researchers keep a watch on these frameworks to comprehend what planets mean for each other's ways, especially when they get close. This assists us with grasping how planets move in space. Now and then, there are rebel planets that don't circle a star and float around unpredictably. These planets might have been important for a star framework but got shot out because of things like gravity or when another star came excessively close. Over the long haul, these meandering planets can go the distance and could run into other star frameworks. Yet, since space is frequently vacant, the opportunity of them hitting another planet is exceptionally low. Rebel planets are interesting contrasted with the quantity of stars and planets with stable circles, so impacts are considerably more improbable when worlds blend. It can disturb the circles of the star frameworks inside them. Despite the fact that planets likely won't collide with each other straightforwardly during these monstrous occasions, gravitational collaborations can change how stars and planets move. Some of the time, planets get flung out into space, becoming maverick universes. Different times, they might slam into one another or their host stars. These interruptions can likewise make new heavenly bodies or structure new stars. The late weighty assault hypothesis proposes that around 4 billion years back, there was a period of expanded crashes involving comets and space rocks. This assault is accepted to have happened on the grounds that the external planets like Jupiter and Saturn were moving around a ton, which upset the ways of numerous more modest articles in space. Thus, these more modest items got tossed onto offbeat ways, many winding up in the internal piece of our sunlight-based framework. This caused a gigantic expansion in impacts on planets like Earth. While these effects didn't include planets impacting straightforwardly, they showed the reality that gravity could make huge changes to how things move in space. This assault molded the surfaces and accounts of planets in our planetary group. It might have even brought water and natural material to Earth, helping shape our planet.
Pluto's recent trajectory has captivated astronomers and space enthusiasts alike, stirring discussions about its potential interactions with Neptune, our solar system's 8th planet. This unexpected cosmic dance has puzzled researchers, sparking curiosity about the implications for our planetary system. Renowned figures such as Neil deGrasse Tyson and Michio Kaku have weighed in on this celestial spectacle, highlighting the need for further investigation. Pluto, once hailed as the 9th planet, underwent a reclassification as a dwarf planet due to its unique orbit. Despite this demotion, Pluto's orbit continues to fascinate scientists due to its elongated ellipse shape, deviating significantly from the ecliptic plane followed by most planets. This eccentric orbit occasionally intersects with that of Neptune, raising concerns about potential collisions between these distant neighbors. While the likelihood of a direct collision remains low, gravitational interactions between Pluto and Neptune influence their trajectories over time. Advanced observational technology has enabled astronomers to monitor Pluto's movements with precision, shedding light on the complexities of its orbit and its implications for the stability of the outer solar system. The intricate gravitational interplay between Pluto and Neptune underscores the interconnected nature of celestial bodies within our planetary system. Despite its remote location and modest size, Pluto continues to command attention as researchers strive to unravel the mysteries of its orbit and its potential impact on neighboring planets. Experts like Neil deGrasse Tyson emphasize the importance of understanding Pluto's orbit, viewing it as a window into the dynamics of space exploration. Similarly, Michio Kaku sees Pluto's trajectory as a valuable tool for advancing our understanding of celestial mechanics and guiding future space missions. While the possibility of a collision between Pluto and Neptune remains speculative, it serves as a reminder of the ongoing quest for knowledge in astronomy. By studying celestial phenomena like Pluto's orbit, scientists gain insights into the fundamental principles governing our universe, paving the way for further discoveries and exploration beyond Earth's borders. Pluto's trajectory through the vast expanse of our solar system has intrigued astronomers and space enthusiasts for decades. Once considered the ninth planet in our system, Pluto underwent a reevaluation that led to its reclassification as a dwarf planet. Despite this change in status, Pluto's orbit remains a subject of intense study and speculation, particularly in relation to its interactions with Neptune, the eighth planet in our solar system. The story of Pluto's journey begins with its discovery in 1930 by American astronomer Clyde Tombaugh. Initially hailed as the ninth planet, Pluto's status as a planet came under scrutiny in the early 21st century as astronomers grappled with defining what constitutes a planet. In 2006, the International Astronomical Union, IU, reclassified Pluto as a dwarf planet, citing its small size, irregular orbit, and inability to clear its orbit of other debris as reasons for the change. Despite its reclassification, Pluto continues to capture the imagination of scientists and the public alike. Its unique orbit, which deviates significantly from the ecliptic plane followed by the major planets in our solar system, has raised questions about its origins and evolution. Unlike the relatively circular orbits of the inner planets, Pluto's orbit is highly elliptical, taking it to extreme distances from the Sun. One of the most intriguing aspects of Pluto's orbit is its occasional intersection with the orbit of Neptune. Approximately every 248 years, Pluto's orbit brings it closer to the Sun than Neptune, a phenomenon known as a Plutino orbit. During these periods of convergence, the gravitational interactions between Pluto and Neptune can influence their trajectories, leading to speculation about potential collisions or close encounters between the two celestial bodies. While the likelihood of a collision between Pluto and Neptune is considered remote, astronomers continue to monitor their orbits closely. Advanced observational techniques, including ground-based telescopes and space-based observatories, have enabled scientists to track the movements of Pluto and Neptune with unprecedented precision. By studying their orbits over time, researchers hope to gain insights into the dynamics of the outer solar system and the forces that shape the paths of celestial bodies. In recent years, the study of Pluto's orbit has been further enhanced by technological advancements such as space probes and computer simulations. NASA's New Horizons mission, launched in 2006, provided valuable data and images of Pluto and its moons during its historic flyby in 2015. The mission offered unprecedented insights into the geology, atmosphere, and surface features of Pluto, shedding light on its complex and dynamic nature. In addition to observational studies, theoretical models have been developed to simulate the interactions between Pluto and Neptune over long periods of time. These simulations take into account factors such as gravitational forces, orbital resonances, and perturbations from other celestial bodies in the solar system. By running these simulations, scientists can explore various scenarios and assess the likelihood of future collisions or close encounters between Pluto and Neptune. Despite the complexity of Pluto's orbit and its interactions with Neptune, the overall stability of the outer solar system is maintained by the gravitational forces exerted by the Sun and the major planets. While occasional perturbations and interactions between celestial bodies may occur, the likelihood of a catastrophic collision or disruption is considered low. In conclusion, Pluto's orbit is a fascinating and complex phenomenon that continues to intrigue scientists and inspire exploration. By studying its interactions with Neptune and other celestial bodies, researchers hope to gain a deeper understanding of the dynamics of the outer solar system and the forces that shape the paths of planets and dwarf planets alike. With continued advancements in observational and theoretical techniques, the study of Pluto's orbit promises to yield new discoveries and insights into the mysteries of our solar system and beyond.